Today, as you can see, we are talking about assignment 1. So there's only a week to do assignment 1, but the coding is really not that strenuous. There's not a lot of code going on. Most of the time will just be spent like downloading the assignment, setting up the environment, and sort of getting used to JavaScript. You can see that for assignment 2, we have a lot more time for assignment 2, but assignment 2 is also by far the largest assignment, in my opinion. You have the most to do. Just a quick note, and I will say this again when it gets closer to it, but I will be away from October 7th to the 10th, or sorry, 7th to the 13th. So I'm going to, luckily that overlaps with midterm break. So this lecture here, Minimax and Alpha Beta, I will record that and post a video of that. So there will be no class, no in-person class on that day because I'll be out of class. But as we get closer to that, I'll make a D2L announcement, so that'll be clear. Okay, so let's get started with assignment 1. So I have some slides, I have a demo, I have the code, and we'll step through it all, and hopefully you will be you'll be ready to go for the assignment. I got a new laptop, so if there's any glitches, I'm going to blame Windows 11. So bear with me if anything goes wrong, but it should be fine. So lecture 4, assignment 1. So assignment 1 is using JavaScript and HTML. I've gotten a number of questions from people, oh, I've never used JavaScript before, I haven't built a website before. You absolutely don't need to worry about any of that because you are given everything except the actual algorithm. And so whether or not you were going to code this algorithm in JavaScript, C, C++, Java, Python, it would be the same difficulty and the same amount of work. Okay? Now, okay, if you were using C, it would probably be a bit more work. But JavaScript, basically all we'll be using, all you're doing is implementing the BFS and DFS algorithms in their iterative form that I gave on the slides. And we're going to be using 4-directional grid movement as the legal actions in our assignment. And so the goal of this algorithm is to get used to JavaScript and HTML. And once you get used to it on this assignment, it will be the same for all future assignments. And then you're going to implement BFS and DFS. All you're going to need to know about JavaScript is basic variable and object usage, for and while loops, if statements, arrays and 2D arrays, which are just arrays of arrays, functions and classes, and any knowledge of the user interface is not necessary whatsoever, but you're more than welcome to look at the UI and see how it works. And I will explain a bit about that code when we get to the code section, but I mean, if you've done this in any language, you will be fine in JavaScript. All right. If you do, like everyone wants to learn more, so if you do want to learn more, there's actually a YouTube series that I hope is still there, and this was the first time I ever used Canvas and JavaScript and HTML5 to actually make a UI. Now, some of the practices in this video may be out of date, but it does explain the basics of how you set up a canvas, how you draw to it, etc. If you're interested in that sort of thing, I'm not monetarily affected by you visiting that channel. I don't know who they are. I just want to give credit to the people who taught me how to do it. So your assignment will look like this. I will load that up in a minute and we will play around with it, but there will be a user interface. So this over here is the HTML canvas element that gets drawn to. There's some instructions here, and then up here there are some configuration options that you can use to change between BFS and DFS, see the solution, run all the tests. There's lots of stuff there for you. So what we'll be using in this assignment, as you can see here, I call this a grid world. So a grid world is a world or an environment that you create that is broken down into grid cells. So you may have seen something like this on a large map in the past, but this is how a lot of video game worlds are broken down under the hood. So it may not look like this when you look at the game world, but under the hood there's some sort of cell-based pathfinding, for example, that goes on. So that's what we'll be using here. In most XY coordinate spaces that you've seen in mathematics, x0, y0 will be down in the bottom left. However, in most graphics applications, and this is no exception, x0, y0 is in the top left, x grows to the right, and y grows down. Okay, so y gets bigger as we go down toward the bottom, and so this is 64 by 64 tiles, or grid cells, and so right here is cell 00 in the top left, and down here in the bottom is 63, 63, because 64 discrete values. So if we zoom in a little bit on the cells, these cells in our grid environment are going to represent the x, y states of the environment that our agent can be in at any given time. And so 00 is in the top left, width height is in the bottom right, actually width -1, height -1. And x increases as we move to the right, and y increases as we go down. So if I refer to a particular cell in the environment or a particular state of the environment, this is what we're referring to. And so if we are ever at a given x, y state in the environment, in assignment 1, we can only move in 4 directions. Okay? In assignment 2, we'll be talking about diagonal movement, but for assignment 1, it's just up, down, left, and right. And so a legal action is represented by a 2-element array where element 0 is the x change and element 1 is the y change. So if I go from here, if I want to move up, right, so down, y goes up, so up, y goes down, because it's just flipped. And so if I want to go from any particular place to another place, I would use this as the action. So to go up, it's a change of 0 in the x direction, because I haven't changed my column, and it's a change of -1 in the y direction. And the opposite of that is for down, so a change of 0 in x and 1 in y. If I want to go left, then those axes are as you're used to. So I would go -1 in the x direction to go left, and of course I'm not changing my y. And to go right, I go +1 in the x direction and 0 in the y direction. So in our assignment, these actions will be what we're using to take a particular state and move to another state. We take the action value, we add it to our current state, and we get the next state. So that's pretty intuitive, hopefully. Now we have to talk about costs. And so the cost of an action is what we want to minimize, right? So the eventual solution will be a path, an ordered sequence of these actions. And then we're going to sum up the cost of each action, and then that will be our path length, or our path cost. And so here, what I've done is I've taken essentially the distance moved, which is 1, and just multiplied it by 100. The reason I multiplied it by 100 is because in the next assignment, we will be moving diagonally, and instead of having 1.412 whatever, I just round that off to 141 so we can work with integer costs. So we'll never have any floating point rounding error or whatever. So I've just taken all the distances traveled and multiplied them by 100, and that's the cost. So for example, if we had a path with 10 actions in it, our cost would be 100 times 10 actions is 1,000 total cost. And then when we find the optimal path, that's the one with the lowest total cost. So, legal actions, how do we define those? Well, first and foremost, objects must be within the bounds of the map. So if I'm in the first column, I can't move left. If I'm in the first row, I can't move up. If I'm in the last column, I can't move right. If I'm in the bottom row, I can't move down. So we can only take actions which keep us inside of the bounds of the map. The object can move in all 4 directions, so up, down, left, and right. This means that if I was up against the left-hand wall, my only legal actions would be up, down, and right. I can no longer move left. The object can only move to a space if it is the same color as where it is currently. And so if it's on a blue tile, it cannot move to a green tile, and vice versa. I'll explain that more with an example. And the object cannot move off of the map. And so it must be within the bounds of the map, and it also cannot move off the bounds of the map. All right, so that's the legal actions. So for assignment 1, our objects, or our agent, is only going to occupy 1 grid cell. Okay, so if I give you the XY location, that is the XY location of the state, which is where the agent is. And in assignment 2, we will get into agents or objects that are of bigger sizes, which introduces new interesting things to the pathfinding, such as getting stuck, etc. But for assignment 1, we're dealing with the easiest possible case of an object just taking up one grid cell, object size 1. So the legal actions, let's say that my object is currently here on this yellow area, and there is green to my left and blue to my right. So this is a blue tile that my object is on. So what are my legal actions? Well, I cannot go to the left because I would be moving from blue to green. So if we picture this as like a video game, I'm in the water, I can't go to the land. That's just sort of what I've visualized here with these colors. But I can go up, I can go right, and I can go down. Okay? Now, inside the assignment, which I'll show you a little bit of, these colors are not inherent to like the problem. They are just how I've chosen to display this. So the way that the environment is actually constructed is just a 2D array of integers. Okay? So I think there's 3 colors in the assignment. There's green, there's blue, and there's gray. There could be a million colors, there could be only 2 colors, but under the hood, that's just an integer. Okay? And I've just hand-drawn the map with these integers and then drawn them in the display as different colors so that they have some intuitive notion to you. But the fact that there are colors makes absolutely no difference. It's just the legal actions say you cannot move from a cell with a given integer to a cell with a different integer. That's it. We are also going to have our node class for doing our search. So in JavaScript, it's really, really easy to define classes. Here we have a class node. You define its constructor. So the constructor of a node is going to take in the x and the y of the state that you are at when you're searching through that node. It's going to take in the action, and the action is going to be an array of size 2 with the x and the y that you have moved. And it's also going to take in a parent variable, and a parent is another node object. The only exception to that is that for the root node, meaning the first node in the search, it has no parent. And so we would pass null into the first node that we create, and also there is no action for the first node that we create because we have just started there. And so for the first node that we create, action and parent are going to be null, and then every subsequent node that we create, the children of a given node are going to be passed in the action of the action that created this node and the parent that created that node. So that's how we're going to keep track of things in the tree. And in assignment 1, you are doing breadth first search and depth first search. And here, like I said last time, the only difference between breadth first search and depth first search is that you use a queue as the open list in breadth first search, and you use a stack for the open list in depth first search. And in fact, it's even easier than this in JavaScript because you just use JavaScript arrays. You're not using a queue or a stack. But what we'll do is we'll always add things to the end of the array. But for a queue, we'll get from the front of the array. And we can do that with a particular JavaScript function. I'll get into that when we go into the code. And it's just a different function if we want to get from the end of the array. So we can use an array to simulate both a queue and a stack just by how we've taken an element from that array. And that's the explanation of the assignment. There's not much else to it. So let's get into a demo of the assignment. So I'm just going to full screen this so it fits. Okay. So here is the environment and the user interface for assignment 1. And again, I know that this looks like a lot, but you are only writing the back-end algorithm. And I'll show you the code in a minute to show you just how easy that's going to be. So the first thing that you can do is let's read the instructions. So it says, I know this is really small, so I'll read it out for you. Left-click and drag to set a start and goal tile. And so the object can only move through the same color tiles in the grid. Click any drop-down menu above to change the search settings. Actually, let me do them one by one. So the first one is click and drag to set a start and goal tile. So the first thing that I'll do is I'll come up here to the search algorithm, and I'll choose solution BFS, because the student one doesn't really do much right now, but I'll show you what the solution does. So I can click and drag, and it'll be calculating the shortest path from the starting tile, which is listed right here, to the goal tile listed right here. And so what this user interface is showing you is that from the start to the goal, this is one of the shortest paths. There can be multiple shortest paths that all have the same cost to get to the goal, and this is the one that my algorithm happened to find, right? So if you think about it, in one case, I might be able to go to the right and then up, but another path is going up and then to the right. They're both valid optimal paths, but your algorithm is only going to find one of them and then stop. So it doesn't matter if you have found a different optimal path, as long as the cost right here, this is 11,200, the cost is the same. That's all that matters. You can also single-click on the start and then single-click on the goal if you don't want to drag around. And in here, I can single-click here and then single-click here. Okay? So that's how it works, and I cannot pathfind through the same color here, and I cannot pathfind from here to here. Even though it is the same color, I need to have an entirely blue area to walk through in order to make that path. So if I open up here the student BFS, you'll see that if I click a start and a goal, the sample code that I have given you just draws a path over and down. That's all it does. It just makes an L-shaped path and returns that as sample code, but you can tell that obviously this is not the correct answer, right? Up here, in the environment map, I can choose a bunch of different maps. So I've got like caves here, really dense caves. If it gets a little dark on your screen, you can toggle off the grid if you want to. That's just a UI. It doesn't change any functionality. It just looks different. Or for debugging purposes, initially, what I recommend is either choosing the blank or the L-shaped wall environment, because you can see them up close, and you can do things like this. Okay, click, click. Oh, this is still the student solution. Let me look at the breadth first search of the actual solution. So this was the optimal path. There is another option down here, which is visualization. So what this says is instant path plus open/closed. So over here you can see that some nodes or some states have been colored in red, and some are in this goldish yellow color. The gold states are the ones in the open list, and the red ones are the ones that have already been expanded in the closed list. And if you actually want to see how this looks, I can choose animate search. So if I click the start and then click the goal, it will show me how the search is going out, breadth first search, and then once we reach the goal, it draws the path for me. So what we're going to have in the assignment is this user interface is going to call one iteration of the search every time it refreshes. So, and I'll get to this in the code to make it make more sense, but essentially, this user interface is updating once every 60th of a second. So ideally, this should be 60 frames per second. And every time it updates, if your path has not yet been completed, then it calls another iteration of that if you're doing the animated search. So if you really want to debug your code, you can choose single step. Now let me choose a start and a goal. And then down here, I can click the single step button, and I can actually go through and say, you know, if all of a sudden I start having red states appear down here, or yellow states appear that are not attached to the red, then this is just a really good debugging visualization to help you debug your assignment. And also looks kind of cool once you use more interesting maps. Another thing, if I reload this, is if I come down here, I can click this button, which is Run Tests. And so I'm going to click Run Tests, and then there are two different types of tests. So the very first thing that the marker is going to do when they get your assignment is click the Run Tests button and then click Random Tests a few times. So this Run Tests button, that is 20 different start and end locations that I have chosen myself and hard-coded to be interesting. So some of them have solutions, some of them don't have solutions, some of them are longer, some of them are shorter. And over here, you can see that it says 7 out of 20. Well, your code doesn't even do anything yet, so how is it 7 out of 20? Well, it just so happens that, the student code just produces this L-shaped path. Sometimes that's the right answer, right, is the L-shaped path. But there are two things here. So it shows the start and the goal, then it shows the cost, and it shows the time in milliseconds that took. So down here you can see that this took 62 milliseconds total, and the student path took 1 millisecond total. So my solution code took 62 milliseconds for all 20 tests, and the student code just took 1 because it's not even doing anything. All right, so you can get an idea of how long it takes, and my rule for the assignment is that you should take no more than about half a second per search for assignment 1. Yep?
For the debugging, different ways to do the debugging, the animated and the step and all that, are we required to program those functions into our code?
I'll get to all of that. It's remarkably simple. You will be doing some of that functionality, but all you have to do is return the open list and the closed list, and it'll do everything else for you. So I'll show you that function when I get to it, but that's a good question. So here, if you click Run Tests, it'll run all of these, and no, if you do nothing, you're not going to get 7 out of 20 on the assignment, right, even though you got those right, because what we also do is click Random Tests, and these just choose random start and goal locations, and everything has to be green. If everything is not green, then that's bad. Okay, and the only other additional thing here is that if there is no path found, then you return -1 as the cost. Okay, so it'll check that as well. What else is there about the UI? I think that's about it in terms of the UI. Oh, there's also, if you get tired of, of seeing all that like red of the closed list, you can choose instant path only. And what instant path only does is it just doesn't draw the open and closed list if you want that. Okay, so that is the user interface, and now I will get into the code. So this may be, let me try and increase the size here. So over here on the left, when you get the assignment, you'll be given a number of different files. So you'll be given the zip file, which contains all the files, and you'll be given every other file in here except that one. You're not getting the solution code, but you are getting the obfuscated solution code. So again, I have given you solution code so that it can run your solution against the solution, and this is what it looks like, right? And trust me, even though this is technically de-obfuscatable, it is significantly more work to do that than it is to just do the assignment. Okay, so the files that you've been given are the marking file, which tell you exactly what each thing in the assignment is worth. A Grid.js, that is just a class that I have made that's essentially a 2D array. Okay, so that lets you do things like get, x, y, etc. I'll go into that. This grid GUI and GUI.js, I'm not going to go into too many details of that, but those are just the two JavaScript files that I've created to make this user interface. So it all gets drawn using JavaScript, all the HTML elements get created and then pushed there in the JavaScript. And those two files, grid GUI and GUI, do that. Index.html, that's obviously the HTML file that runs everything. And then there is search_student, which contains the skeleton code, which I have written for you, which you just have to fill in. So the first thing I want to do is go over the HTML file. So the HTML file, the thing I want to kind of look at that is here. You can see all the different maps that I've hand-coded in here. So this is the blank map. It's a 32 by 32 of all 2s. And inside the UI, there's just an array of colors. So array 0, I think, is gray, array 1 is green, and array 2 is blue. And all I do when I go to draw the environment is look up the color and then draw a particular color on the environment. Here is the L-shaped wall map, so you can see the zeros there, so that's the gray color. And down here you can see this is the default map, which is sort of the interesting looking environment. And these are all stored as integers, and then JavaScript takes the text, reads it in, and transposes it, and just stores it in a grid. So then all you have to do is say this.grid.getXY. So all that is done for you. Okay? So that's the HTML file. Nothing else is really interesting. Here, it just creates the UI element that my class is. It gives it a container that it's going to be drawn to. It says call the update function 60 times every 1,000 milliseconds, and then the update function just calls the draw function inside the user interface code. So it just gets drawn 60 times a second. That's it. That's the entirety of the HTML besides the CSS. Okay? The next file that I'll show you is the grid class. So the grid class is what you use to get access to the environment, the different states of the environment. So here I pass in some text to the constructor, then I split it, and I just set up a 2D array. That's literally all that happens here. And you can see here that once I get into the code that you have to write, there's a this.grid variable. And if you want to get the XY element of this grid, then it'll return this.grid. But as some keen students have pointed out, this.grid, or in the past, it says YX instead of XY, and that's because when you read the text, you read it row by row instead of column by column. So the grid is actually stored Y first and then X, but if you just use the get function, I just switch those around. So for all intents and purposes for this assignment, you just call this.getXY, and it'll give you an integer representing the color, or what type of tile this is. And if you want to know if you can move between one state and another state, you'll just check, is this.getXY equal to this.getX2Y2? And if they're equal, then you can move between them. This is a function that I have written here for you. It's called isOOB. IsOOB, it stands for is out of bounds. And so what that does is it checks to see if a given XY location is not contained entirely within the bounds of the map. So when will that happen? That will happen if X is less than 0, if Y is less than 0. This size variable, so this is the same code that I use for assignment 2, in which we do have a size. So wherever you see size, and I think this is the only place you will see size in assignment 1, just make sure to pass in 1 as the argument for that. Okay? So 1 is the size. So I'm saying if x plus size is greater than the width, then it's out of bounds, or if y plus size is greater than the height, then it's out of bounds. So if you ever want to know if a particular location is actually outside the bounds of the map, I've got a function there for you. I mean, you could do it yourself as well, but this is probably easier to do. And that's it. That's the entirety of the grid class. It's just kind of a wrapper around a 2D array that also reads the text of a given environment and converts it into integers in that grid. Any questions at all about that grid class? Perfect. Okay. As you can see, I'm using VS Code. I recommend using VS Code for the assignment. It's a great editor. You can use any text editor that you want. Now, one thing that I should mention is that I've noticed a lot of students in the past, when they get their assignment, so for example, you have assignment 1 here. I know this is a bit small. All you have to do to run the assignment is double-click the HTML file. It just runs serverless in a local browser without connecting to anything. Some people have set this up in like JetBrains IDE to like run a local web server and then serve this page. Absolutely don't do any of that. It might still work, but just load the HTML file in your browser, okay? And I think that some people have Visual Studio, actually, or VS Code, geez, not Visual Studio. Visual Studio and VS Code are two completely separate things. I hate having to say that, but it gets confusing. So some people have it set up that there's like a run button in here, and when you click run, it will launch a little web server and serve the HTML page. Don't do that. Just edit your code, then go back over, then hit refresh. That's all you have to do, and it'll refresh everything. If for some reason your changes are not reflected, then there may be caching going on. I haven't run into this with anyone in any major way, but you can. I think it's like Control-Shift refresh or Control-Shift-R, and it'll do like a refresh and clear the cache for that page if your code changes are not being reflected properly after you've edited. Just make sure and save it, and then hit refresh, and you'll be fine. The next file is this GUI.js. This is just me. I've written a bunch of classes for really easily making these UI elements. You absolutely don't need to worry about that at all. And grid.GUI.js, this is the big one. This is what sets up the entire thing. The only thing I wanted to show you here is that you get like object sizes. It keeps track of where you clicked, the initial state and the goal state. Here's the colors. So the colors are just represented by their hex codes. So this is gray, this is green, and this is a dark blue. And so when you get this.get or the grid.get xy, that is the index to look up this color. Then down here, I add all the event listeners and everything. It does all the animation stuff, and it's like, you know now why I don't want these assignments to sort of be leaked online, right? It's a lot of work to do something like this. Feel free to have a look at it if you want, but you don't need to understand this code for the assignment. The next one is searchStudent.js. So, first, let me go back to the slide. So, this is the BFS algorithm. It has two parts. One is sort of the setup part, where you create the open list and you create the closed list. And then is the part that's within the loop, right? In the while loop. So this is sort of the algorithm, and this is the setup. We are going to split this up in a minorly different way for the assignment. So whenever you start a new search, which is initialized by clicking a start and then clicking a goal location, that's where you'll do the setup, okay? So you're going to record where the start is, where the goal is, you're going to set up the closed list, and you're going to set up the open list. There's a function there that I'll go into in a bit that's called startSearch. That's where you do this part. Next, there'll be a function called searchIteration. And what searchIteration does, as it is so named, does everything that's inside the while loop, but it does not contain the while loop. That's because my user interface is the while loop. So every 60th of a second, my user interface calls this code right here. So do not write the while loop part of the algorithm inside that function. That's the only difference here, okay? And my code will call it, and in that way, what happens is I can do things like animate the search, right? So at any time, I can call one iteration of your search if you call that step function. So let me just do that once more. Go back to the assignment. So if I click right here, and I click single step, and I go from here to here, I haven't called your search iteration yet, because the UI handles the calling of the search iteration. If I call single step, oh geez, okay. Well, that was interesting. If I call single step, one iteration, another one, you know, DJ Khaled. It just keeps calling single search steps. If I change it to animated search, then it calls the search iteration function 60 times per second. If I change, and also you can speed that up if you want. If I call instant path, what it does is it continuously calls your search iteration function on that frame until the path has been completed. All right? So it is the while loop. That's the only confusing part about this assignment, is that you don't write the while loop, the UI is the while loop. And this will be more clear when I get into that part. Okay. So let's read through the entirety of this search student, and then I may do some coding to give you some examples. So all of your assignment 1 code should be in this file. It is the only file submitted. So on D2L, for all of your assignments, you will only be submitting one .js file. It's usually whatever underscore student.js, and D2L will physically not accept anything other than a single JS file. And I've set up D2L so that it only accepts that JS file, and you can submit as many times as you want, and it will only keep the most recent submission, or the last submission. Okay? So if you're getting close to the deadline, you have something that works, but it's only like 80%, submit that, and then go try and finish the rest. And if you don't finish it in time, well, at least I got the thing that did work. Okay? And I literally cannot see any previous submissions. I don't even think I can see that you have submitted multiple times. You may create additional functions or member variables within the class, but do not rename any of the existing class variables or function names, since they are used by the GUI to perform specific functions. Okay? So why did that happen? So that means that if you want to put in an extra function in there or an extra variable that'll help you out, that's completely fine. But the UI uses the existing ones. So if you rename search iteration, everything will break. So just don't do that. And another note is that since you're only submitting this file, if you edit any of the other files for any reason, which you probably shouldn't, but if you did, those changes will not be submitted to me. So if you did edit any of the other files, let's say you're a super keener and you really wanted to edit the UI to do something to help you debug it, then you can, but that will not be submitted to me. So make sure that this file works with the files that I gave you with the assignment. All right. Your group, if you are working in a group, submits one file total, not one file per person. Make sure both names are entered somewhere. And when you get this file, it will have your name, your student number, your email address, a bunch of other ways that that information is encoded into these files that you can and cannot see. And so just at the top of this file where it says your name, just comma your partner's name for the assignment. And then we will mark the one assignment and give you both the same grade. Unless there is some crazy fight about the other person not having done anything, we don't ask for any proof of who has done what work. Please both contribute, but you're both responsible as well as you both get the same grade. All right, so in this file, you will see this search student class. And again, don't rename it. So that's the search student class. There is, in the solution code, there is a search solution class. And then the UI, when you switch between breadth first search and depth first search, it passes that into the appropriate class. So if it said solution, it'll use the solution class. If it said student, it'll use the student class. So inside the constructor here, the UI will gather all of the configuration options from the UI, and it will pass it in here as an object. So this is a JavaScript object, and you can set and get different parts of this configuration. So the parts that you have to be concerned with are config.actions. That is an array of legal XY actions. So each action is going to be like 0, 1, or 1, negative, or -1, 0, whatever. So this will be an array of arrays of size 2. For this assignment, that'll just be the 4 legal actions. In assignment 2, we're going up to 8 legal actions. Config.actionCosts is another variable. That's another array of, in this assignment, 4 elements. And so config.actionCostsI, that is the cost of config.actionsI. So the cost of the first action in this array is the first element of that array. The cost of the second action is the second element of the action costs array. It's pretty intuitive. And there will also be a string here, which is config.strategy, and this will either be BFS or DFS. And I forgot that I didn't look at the DFS part yet. So let's go back to the assignment. So here, in the assignment, there's 2 things. There is solution BFS, and there's solution DFS. Remember what we said about depth-first search. It may not find the optimal path. And it pretty much just finds the path in whatever order that you have chosen the actions. So if I go up here, and I click here, and then here, for example, you can kind of see the order in which I iterated through the actions in my loop of generating the children. So I'm going to go to the left, then up and around, and it's just whenever I happen to find the goal. So DFS, your DFS will not be optimal. And if you click Run Tests, it will be horrendously wrong, but we are only running tests for BFS. So I'm still going to get questions about this, even though I'm repeating it. Do not run tests for DFS. Do not worry about the costs of your DFS. Do not worry if your DFS looks nothing like my solution. As long as it gets a path, that's all that I care about, is that it worked because it found a path. And also, if you look at solution BFS, for example, if I click there, and then I click there, well, there was no path, right? Because it can't get there. A common question that I also get is, if there's no path, why didn't everything fill up in red, right? Because as I'm searching, there's a big closed list. The answer to that is that my solution has a bunch of optimizations in it that makes that not necessary in this case. We'll get to that in assignment 2. So this is going to look different for yours. So if you click here, and then you click here, basically all of this blue should be red. That's the only difference, is that I got a bunch of optimizations. I didn't want to have to write 2 different solutions for the 2 different assignments. So if yours doesn't look exactly the same as mine for some things, don't worry about it. And again, if the DFS doesn't look exactly the same, there were some optimizations in my code that make it like skip over even lines or something like that. Don't worry about that. Just worry that your DFS actually found a solution. That's it. Okay, so I should have explained that before, but at least we got to it. So those are the 3 things in the config: the actions that are legal, the actions that are legal in the environment, the cost of those actions, and the strategy. Next, inside the constructor, so if you've ever used Python and you got sick of typing self dot to refer to class variables, in Java, I think Java, and as well as JavaScript, it's this dot. So a this dot, this is essentially a pointer or a reference to the class that has been instantiated, and then dot whatever the variable name is. So I have some variable names here. This dot grid equals the grid that's passed in. So that is the grid object that contains the particular environment that you've selected. So again, you can call this dot grid dot get xy to get the integer, etc. I also have this dot sx and this dot xy. That is the x and y locations of the starting state. And then I have this dot gx and this dot gy. That is the x and y location of the goal state. And I have this dot cost. So these are the start and the goal states, which you will use to be checking if you've reached the goal or not. And also, I have this dot cost. So once you've computed whether or not there is a path, so there's 3 possible outcomes. One is that you've searched everywhere and no path is possible, in which case you'll set this to -1. Or you have found a path, and so you'll add up the cost of all the actions in the path and set it here. Or your search hasn't finished yet, in which case you don't modify that. And so at the start of each search in the startSearch function, these values will be modified. Then there's another variable here, which is in progress. That just says, okay, if a search has started but has not yet finished, then in progress will be true. So you can use that to see if you're currently searching or not, and the UI also uses that. This .name, that's actually not used. And then there's the path, which you will return. It's initially empty. If you find a path, you're going to populate that path. This .open, that is the open list of nodes. And this .closed, that is the closed list of states. So those are all the variables for the search. And I know this seems like a lot right now, but it's really not going to be that bad once you start programming it. It's just all the variables that you need. Okay, so the first function here, and I've done all the, you don't need to write another variable or another function. I've written all of the skeleton code for you. So let's go through this one. This is the startSearch function. Its arguments are sx, sy, that is the x and y position of the start state, and gx, gy, that's the position of the goal state, and it doesn't return anything. This is called by the user interface. So you never have to call this function. This is called after the mouse clicks are done. So it says, this function should set up all the necessary data structures to begin a new search. This includes, but is not limited to, setting the start and goal locations, resetting the open and closed list, and resetting the path. I have provided a starting point, but it is not complete. And so we're going to look at this startSearch function. Here it is in its entirety. I have set up these variables for you. So every time a new search starts, let's think about what we have to do. Well, we have started a new search, so we set that variable to true. We set the start and the goal x and y's, so I've done that for you. You don't need to do that. And I also set the path to be empty, because we haven't found a path yet, we've just started. Everything else that you need to do to start a new search is you need to do here. So if you look up, I've kind of done that for you. This .open equals empty array, this .closed equals blank array. You can completely just copy and paste that here, right? Anything else that you need to do the new search, but it's just setting of the open and closed list because I've done everything for you. In assignment 2, there will be much more stuff to do in the startSearch function. The next function is isLegalAction. So this function should compute and return whether or not the given action is able to be performed from the given xy location. So the arguments, we have first an x and a y. That is the xy location of a particular state in the environment. And then we have action, which is an array of size 2 containing the x and the y direction of the move. So the action to be performed representing the xy movement from this position. For example, 1, 0 is move 1 in the x direction and 0 in the y direction. For this assignment, the only actions possible should be those. Do not copy and paste those and iterate through them. Use config.actions. That's where those actions are stored. And so down here, what you have to do is the following. So let me go back to the slides. You're essentially computing this. So I'm going to give you a given xy location. So that is the yellow location here on the map. And then I give you an action. So for example, if I give you 0, 1, that is down. And so you should compute something and then return true. If I give you -1, 0, that is moving left. And so you should compute that and then return false. Why? Well, here's the logic behind that. If I take in the x value of the state and the x value of the action, and I add them, I get the resulting x coordinate. If I take the y coordinate of the state and add the y coordinate of the action, then I have both the x and the y of that new state or next state that I'm trying to get to. So once you have the current state's xy and the next state's xy, you're going to call this .grid.get on both of those and then compare their values. Okay? And if they're the same, then it's a legal action. If they're not, then it's an illegal action. The only other case, which case am I missing?
The edge of the map.
The edge, right? So whether or not it's out of bounds. If the next state is out of bounds, it's not a legal action. So in here, that's what I said. First, create nx, ny, the new location action after the action is performed. I've actually already done that for you. So step 1 is done. 2, if this.grid.isOOB, then that means if this is true, then it's out of bounds, so return false. Otherwise, if this.grid.getXy is not the same as this.grid.getNx, ny, then return false. A common mistake here is doing the second check before, or the third step before the second step, is doing the check to see if they're the same first. But the error here is that you may be checking an xy that's off the map. So if you check this.grid.get with a negative value, you're going to crash, right? Because you're indexing the negative element of an array. But checking to see if it's out of bounds first eliminates that case because you've done all the check to see if it's out of bounds before you check to see its value. Okay? So the order matters there. And then the next function, as you can see by the description, is the search iteration function. So let's have a read through that. This function performs one iteration of search, which is equivalent to everything inside the while true part of the algorithm pseudocode in the class notes. The only difference that being when a path is found, we set the internal path variable rather than returning it from the function. I'll repeat that again when I get down to that part. When expanding the current node, you must use the this.isLegalAction function above. If the search has been completed, either the path is found or the open list is empty, then this function should do nothing until the startSearch function is called again. This function should correctly set the this.inProgress variable to false once the search has been completed, which is required for the GUI to function properly. So what this means is that once your search is finished, you set this.inProgress to false, and then at the beginning of this function, you're going to check to see if this.inProgress is false, and if it is, you don't do anything. I'm thirsty. Okay. This function should perform one iteration, meaning everything inside the while loop, of breadth first search if this.config.strategy is equal to BFS, or one iteration of depth first search if this.config.strategy is equal to DFS. There should only be a few lines of code, in fact, one line of code difference if it's done correctly. If you do copy and paste both entire versions of the algorithms, you'll lose a few marks, even if it still works. Tip: you can use a JavaScript array to represent a queue or a stack. So array.push an element, pushes an element to the end of the array. You can use array.pop to return the last element of an array, simulating a stack. You can use array.shift to return and remove the first element of the array, simulating a queue. So you can just use an array and use one of these things. You may also use your own custom data structures if you wish, but they are not necessary to receive full marks on this assignment. We will be getting into optimizations of this once we get into assignment 2. And all of those things we'll be talking about in assignment 2 for optimizations are implemented in my solution code. So if you go to run your code and it's slower than the solution code, don't worry, I just haven't taught you all the things that make it faster yet. Okay? But again, less than a second per path for sure. And that should be no problem to hit. So, search iteration. So what I've done here is you have to delete this code and replace it with one iteration of the while loop. But I've just showed you some sample code here to show you like how to set a path, for example. So the example here is for simple demonstration, compute an L-shaped path to the goal. This is just so the GUI shows something when student code is initially selected. Completely delete all of the code in this function to write your solution, except this line of code, which says that if there's nothing in progress, if I'm currently finished my search, then just return. So leave that there, and that's how you skip this function when you're not doing anything. So what does this do? This computes an L-shaped path in a single step. So all I do here is I figure out the difference in x between the start and the goal, the difference in y between the start and the goal, and then for that difference, if it's a horizontal movement in a given direction, I push a move in that direction. If it's in a vertical direction, I push a move in that direction. So all this code does, I'm not going to go into exactly how it works, but you can have a look at that. And whenever you want to add an action to your path, then you this.path.push, and you put that action in there. Okay? All right. So that's just a sample code. This sample code I have given you as well. So it says, if this.config.strategy is equal to BFS, do the breadth first search. If this.config.strategy is DFS, do the depth first search. So you can keep that if statement there and use that one if you want to. Note, do not duplicate all of your BFS and DFS code in the if statement above. You should only include what is different between the two algorithms. So what you should kind of do is write your algorithm around this. If it's BFS, then you're doing one of shift or pop. If it's DFS, you're doing the other one. So that's the difference between the two algorithms. And then the cost of the path for this assignment is the path length times 100. So there's a bit of a shortcut to computing that. If you've done 20 actions, all the action costs are 100. So I say this.cost equals this.path.length times 100. The only other thing you would do here is that if the open list runs out of things before you found a path, then no path is possible, and so you would set this.cost equal to -1, because that's what the tests are going to run. And then once you've finished, you set this.inProgress equals to false. Now, you don't put this at the end of the function all the time. You only set that when your code is, when you have found a solution or proven that there's no solution. Was there a question over there? Yeah?
Will that if statement work here? Because like I remember that in Java it should not work because these two strings.
No, this works. Yeah, yeah. So you can do string comparison like this. That's fine. Okay, on to the next function. This function is called getOpen, and you're going to return the states that are represented in the open list. So this function returns the current open list states in a given format. This exists as a separate function because your open list in the search stores nodes, not states. And so it may have a custom data structure. You may be storing them in a particular way. But in order for the UI to operate properly, you have to return for me an array of unique XY states that are currently in the open list. So let's just look at how you may do that. So we have this.open. That is our open list that we have. That's going to have a number of elements. So I could say for let I equal 0, I less than this.open. Oops, I already have that there. I can't remember if it's .size or .length, but whatever. So here we go. We are iterating through the indices of that array. And so I've got a node now. So this.open I That is a node. What I want here is an array of states, x, y states to be exact. So this array.open, or sorry, the node, if I go down, contains an x and a y. Okay? So if I come back up, I can get access to this.x, and I can get access to this.open.y, and then I'm going to put those inside an array, and then let's just say when declaring a variable in JavaScript, you can either use let or you can use var. Under no circumstances in this course will you use var, because that allocates it in like a global scope instead of this being the correct local scope that you're used to. If you allocate something with var and then you leave the block of code, it lives somewhere. And it has caused infinite confusions. And like I have corrected assignments from students going out of their mind by just changing var to let before. So I'm not sure exactly what's going on, but just use let instead of var whenever you're declaring any variable in general in JavaScript. So I can say let open states equal a blank array, and then down here I would add this thing to the open states and then return open states. Okay? I'm not going to exactly do that because I want you to have something to do for your assignment. And then down here is the same thing but for the closed list. And if you haven't changed the closed list from its naive implementation, then you can probably just type return this.closed. So if your closed list is already in this format of unique x, y states, then just return this.closed. If you have used some other data structure to store your closed list, then you have to convert it to this first. This is the node data structure. You should not need to modify this in this assignment. Okay, so don't change the node data structure unless you're doing something crazy, but leave the crazy stuff for assignment 2. You only have a week for this one. Okay, so one note that I will show that often trips people up is once I've found a solution, how do I get the path from that, right? So what you can do is in your search, let me go back to okay. So we have a search tree. We are at right here, for example. So this is a node. How do we get back through to find all of the different actions that we did? So each of these nodes is going to store the action that created it. So when I found the solution, I'm at the goal node. I'm at a node which has a state equal to the goal state. So what I can do is I can say, okay, if the parent of this node is not null, go to that parent. And if the parent of that one is not null, go to its parent. And you keep going back and back and back and back until you get to a node whose parent is null. And if it is null, then you've reached the root node. And so what you've done is as you traverse, you go back and back and back. You're saying, okay, I have this node, take its action and add it to the path. Then go to its parent, take its action, add it to the path. Go to its parent, take its action, add it to the path. And then you've got the ordered sequence of actions for the path. But who can tell me what is not quite correct about that? Has anyone spotted it? Yep.
Wouldn't that put it in reverse order?
Exactly. Okay? So if I'm starting with the action that I took to get to the final state, then the second last action, so my actions are now going to be in reverse order. So what I do is I add it all to the path, and then I just reverse what's in the path. And there's like JavaScript functions for reversing an array, or you can do it yourself. And so that's the last tricky bit, is just setting up that while loop that says while this node's parent's not equal to null, check the action, add it to the path, and so I'll leave that. But that's what you have to do there, is check those parents. And just let me double check if there's not anything else. Okay, so the thing I will leave you on is just remember, sorry, marking scheme. I want to show you that before we go. So here's the marking scheme of the assignment. For the first assignment, there are 10 points for code style, modularity, readability, 10 free points as long as you follow the same style. Don't have 20 lines of white space doing nothing. We actually do look at the code. I want you to be better programmers overall, follow a decent style, and have nice, clean code. If you have anything that you did that's extra to make it faster, write a comment to explain it to me, because I may not understand what's going on. Functions used where appropriate. So for example, the isLegalAction function is used. Data structure, so make sure that you're using the queue for the BFS, the stack for DFS. Other functions, so startSearch, isLegal, and getOpen are all done properly. Then we have the most points is that the BFS pathfinding works and is giving the correct results. 1 second per path at most. The GUI properly draws everything. The visual inspection of BFS shows proper behavior. So the TA will run your code, choose animated search, and will see it growing properly. And oops, I left this in there. That's when this was piggybacked with a grad course. Ignore that. If that's in there, just ignore that line. And then the DFS produces a path to the goal, properly interacts with the DFS, and I just see it working in a similar way. Total assignment mark 100. So if you load up your assignment, once it's done, you click run test, you've basically got an 80, and the only marks you'll lose are like if DFS doesn't work or if your code style is horrendous. Question or yawn? Okay, no worries.